Hi, everyone. Thank you for joining us today as we present a webinar discussing how to model conventional survey data. So this includes total station and RTK GPS systems. So it's actually quite easy to import conventional survey data into RoadEng or terrain tools once you know how to set it up correctly. And that's really what we're going to focus on today. So today's content really is, as I mentioned, focusing on conventional survey data and how to create accurate terrain models. So this includes the setting up of a reusable import format, how to create break lines, how to fix those break lines when they happen to cross, how to work with symbols and line types, and then finally, it'll also cover some techniques for exporting data, whether this is back out to machine control for slope staking and construction, or even just back to a total station. So we will tackle that. Today, we are going to be focusing on the terrain module of RoadEng. And so for those of you who are not too familiar with it, RoadEng is a modular program. We've got survey, location, and terrain. And terrain is where we're going to handle all of our conventional survey data. This program also, you want to know, it is available standalone, is just something that we call terrain tools. So that's a bit about our content. I did just want to cover two sort of introductory concepts before I pass it over to our technical support engineer, David. First, let's talk a little bit more about these reusable import specifications. So import specifications are a way of describing to the software how to interpret the data that's coming in from your survey file. The software is going to read in the file and parse it according to these specifications. The specifications themselves are totally reusable. So once you go through the effort of creating one, you can save it. And then if you collect another set of survey data in the same manner, you can reuse the format and skip all of the initial setup. So it's very helpful. The import specifications, as I mentioned, are going to save you some time after that initial setup. They include structural elements for your survey file, whether that's the column assignment, whether it's tab delimited, comma separated, etc. It allows you to automatically join features and create polylines, giving you consistency in your line work for those items, as well as attaching symbology to other properties. There is one big caveat with import specifications when you're automatically joining these features and creating polylines. If your features are identified by their side, for example, with a left and right for road edge or ditch line, it is going to really help to improve how they import. So two quick examples. The first here on the left is what happens if you use the same point code for both sides of, say, your shoulder. So the software is automatically going to join it zigzagging across the road, which obviously not too accurate. If we were to denote these with lefts and rights when the survey data is collected, it's going to import really nicely using those point codes uniquely for each side. The other piece of introductory concept I wanted to cover before I pass it over to David Mills is a little bit more about break lines, or strings, as some people call them. So as you know, break lines are polylines that are used to connect survey data representing a distinct feature. This could be a shoulder, an edge of pavement, toe of slope, etc. The data is interpolated between the known survey points so that the entire line has a known elevation. Now, break lines are usually essential for the creation of an accurate surface model. And it is the interpolation of the data, not just the data itself, the survey data, I should say, itself, that determines the shape of the model. And when these break lines cross, it can actually be a bit of an issue. So crossing break lines cause a conflict between the two different interpolated elevations. And really, we're going to spend a bunch of time in our webinar today discussing in detail how we can find and fix these break line conflicts. So figuring out where they cross and how to fix them. And with that, very long introduction, apologies guys, I'm going to pass it over to David. David, are you here?
I'm here, I'm ready. Thank you, Erin.
Okay, it's coming your way.
Right, let's get started with our terrain module. So I'm running version 9 of our terrain module. This is where we do import to make various maps and surfaces. So I'm going to import some total station data. Let's take a look at a fairly typical total station file. I've got one here that contains both a road and a creek, and I've got an import format that works perfectly on it. Before I do that, however, I'm going to bring it in with basically no information about the points. So this is my file, and I'm going to import it. Here's our import options. Every time you import a file, it doesn't matter whether it's ASCII or not, but in this case, it's an ASCII file, you get all the options. So these are the options for importing ASCII, and it's telling me the point code. Here's the point code stuff. Basically nothing in there yet. Here's the structure. My file is in the format point number, northing, easting elevation. So I've set up the columns to do that. And here's the test tab so I can see if it's working. I'm just going to collect a few records, and yeah, it looks good, looks fine. And in fact, except I think I missed the first point because I had this thing set, which was incorrect. Let's change that to a 0. And I think this is going to work. So without classifying my points, here's all my survey data. All I know about each of these points is that it has a well-defined elevation. So there's point elevation 80, and here's one, with elevation 80. Here's another point with different elevation. And from these XYZ points, I can make a surface. Let's just do that quickly. And I'm going to skip the contours for now. I'm just going to make a surface and show you what that looks like in our 3D rendering tool. Here we go. There's my surface. Now, remember what that looks like. It doesn't look very realistic. We've got these big triangular facets that don't really seem to represent a realistic ground. It's kind of in the ballpark. I mean, I can see there's a road in here, and this looks like it might be a lower part of the model. Now watch what happens when I bring in the same data that has been made into breaklines and other colored line work. So let's just reopen that same file. This time I'm going to choose an import format that I've set up already. So here's the same data, same options for setting up my import format, except this time the codes have been well defined. Some of them have been made into break lines. They have different line types and colors. And let's take a look at that. Okay, so now my data looks, first of all, way more organized. It's organized into strings that is connected points to make polylines, and those have been tagged as break line, almost all of them. That means that when I create a surface, again, I'm going to skip the contours for this, it looks a lot smoother. And even if I turn off the display of the features, which is giving me a lot of hints here, you can see clearly that this is a nice smooth model. Although it's still made of triangular facets, they seem to be organized in the right way to define a nice smooth roadway, a creek bottom, and look, there's a crossing here. You can see that this is a bridge abutment. So that's the magic of break lines. When we have break lines that are defined, the software will build triangular facets that align with the break lines. And as Aaron says, that means the elevation along the break line is interpolated between the data points and is actually a straight line between all the points. Right, so how do we get there? Let's go back again to setting up the import options. So let me start from scratch. I'm going to open that same file with the settings that have not been initialized. Basically, these are the settings that come with the software, and the structure is almost right. In fact, I think it's good. The structure here, we can control how the file is represented. By the way, what does this file look like? Let me just open it up for you. Point code separated by a comma is northing, then easting. So it's not XYZ, it's YXZ. Then elevation, and finally a point code. Usually 2 or 3 or 4 characters. So when I'm reading this file, I want to tell the software, yes, it's comma delimited, and it has, let's look at the file. The test tab can help me determine what's in the file. Basically, it's just doing the same thing that text editor did, but just for a few records. And I can see that it's putting the X in the, that's this one here is X, that's good. And then Y is that one, that's good. Z, okay, so it's doing the right thing. It's putting the XYZ in the right fields. It's extracting them from the correct columns. The point code is coming from column number 5. You can just change this here or type a number. You have the option to also name the feature as it comes in and add a label to the feature. These are a bit redundant because the feature name can be used as a label if you like. So I'm just putting the point code in as the feature name, and I'm also using the point code to create a comment, and that's my first attribute. And I can add other attributes too. So typically for survey, you just want to put in the point code and the point number attribute. Those are already in there. And if they weren't, I just add them here. And each one of those has a position 2. So you can see the point number is coming out of column number 1. Now I'm using all my columns. Point number comes from column 1, X from Y from 2, X from 3, Z from 4, and code from 5. So that's basically everything that you need to read the file. There are some files can be fixed width. We rarely see those, so I'm talking about a delimited file here. In this case, comma is used to separate records. I don't have to count characters, but we do handle a fixed width file, which might have, for example, X starting at character number 17 and Y starting at character number 25. But that's like I said, it's pretty uncommon. Almost all total station files I've seen look like this one. Point code YXZ, pardon me, point number YXZ code. You can sometimes have a header, and you can skip header lines here. So if the header had 2 lines in it, you could just skip those first 2. And advanced records. Carriage return line feed is almost always the line delimiter. You'll see those characters here being skipped as well. I'm not sure if that's necessary, but I know this works, so I'm not going to change it. And you can change what's on the end of your records. Almost always it's carriage return line feed. And you can also exclude records here. Usually people just want them all. You can deal with the records by point code in the codes tab, and we'll do that instead. So this is pretty much just take the default. Features, identify features by code. Again, it's that codes tab. We'll be in there in a sec. So use the recommended. There is one thing in here that is useful. Terminate characters. Sometimes it makes sense to tag in the field your the point code at the end of a string or break line. And I've got the exclamation mark tagged here, set here. I don't think it will be used for this file. It's just going to be ignored. Here's where the real work begins, in the Codes tab. So in the field, my surveyor picked up points with his instrument, and every time a point was entered, he tagged it with a piece of text. I think on modern instruments, this is as easy as picking from a drop-down list. Here's all the point codes that are in the file. Click on the load button. There they are. So in this case, break line 1, I'm not sure what that represents, but it's a kind of break line, BL1, has been broken into 4 pieces. And if you don't break if you don't put in unique point codes for each segment of the break line, then you need to deal with it later. And a typical example of that is a ditch line. You're surveying a road. Every time the ditch goes under a driveway, it disappears and then it reappears on the other side. So you might have a point code called DL, and yet if you joined them all together, you would be putting a ditch through people's driveway, so you need to stop and start. That's what this is about. And the way you handle it is, first of all, you make the BL feature into a polyline. Could connect all by code works great, and that means that if I put in a wildcard here, BL star, I'll get a separate polyline for each BL. So connect all, but check the code to make sure that they match. And that will break the BL up into 4 segments. And now that I've created that, this one is not necessary anymore because it's handled by BL star. So the wildcard star handles anything that follows BL, and I'll just remove those. Center line, same thing. Now I could just do all the work I just did there. Actually, I'm not finished. Polyline, connect all by code, break line, yes. And let's give it a line type and color. So you can choose what it's going to look like in your drawing when you're finished. Same, you can change the symbol if you like. And that's good. Include a model is important. That's going to be part of the surface. Now I could do all the same work for CL, but here's another way. I'm just going to add a new one. I'm going to call it CL star, and notice that it copied all the properties of the one that was selected when I created it. And it's going down to the bottom here. So let's change its line type and color. Center line should look different from the break line. Oops, missed. And it's right down at the bottom here. I'm just going to shift it up to the top. And again, I've created CL star. I don't need CL 1, 2, 3. I could keep going, but let's just see what that looks like. This is typically the way I would build a setup. I would do a little bit of work. I'd look in my test here, next record. See, it's joining those into a feature, BL1. And then when I get past the BL1s, it makes a new feature for BL2. Okay, so I tested in here. I set up a few things, and then I try it. Let's see what it does. There we are. So it doesn't look as good as the final result I showed you earlier, but you can see that we've got the center line here and another center line there. And there's my BL2, BL1 on the other side of the road, BL5, I'm looking up here for the name because I named them after the point code. And there must be a break across here where the creek goes through. So those should not be connected. Same with the center line, it should not be connected across there. Now, what if these points are not in the right order? And this happens all the time. So I'm going to open, using the same format that I've been working on, I'm going to open a file that doesn't have the points in the right order. And I'm using the right import format. Nothing has changed here. I've still got the point codes that I set up. And I'm going to open the file and see what it looks like. Okay, so this break line here looks great. That's BL2, but this one, it doesn't look so good. What's going on? It turns out when you do a connection of the points at import time, they have to be in the right order. So when you're creating a break line from nothing, using, well, not from nothing, but using the survey import, let me just do that again. When you use this option, connect all into a polyline, the points in the file have to be in the right order. So if they're not surveyed in the right order, then you get the results I just showed you. Back here and reopen it. So maybe instead of surveying as a polyline, or pardon me, instead of importing as a polyline, I should have just imported points. But you can fix it after the fact very easily. So here's my first fix up. I've got a bunch of points that are called BL1. They have been joined, but they appear to be in totally the wrong order. I could go through here and try and connect them up by hand, but here's a trick that usually works. So what I'm going to do is I'm going to break them into individual points with the explode function. They're still selected, but now there's 12 features instead of 1. And then I'm going to join them back together. And the join operator checks the proximity of the points and tries to connect them into a sensible line. So in this case, break all or explode and then rejoin fixes up my problem. Okay, now I've gone to a bit of trouble to set up this import format. How can I save it for future use? So that's done in here in the setup, module setup, import tab. These are all the import options. So this is the one I was just working on. Now, if you want to just update so that it's available for the future, just click on your save as default and it goes into a little file on your hard drive and it will be used as the default import settings for new terrain files. But if you want to save it for somebody else, or if you want to divide things up, I've got a bunch of these files on my computer, mostly from helping customers. Normal is the default setting file. So if you update that, that will be used for new terrain files. And if you want to do a save as, you can give it any name and write over it. However, I recommend that before you do a save as, if you want to use the merge operation on some other computer, or if you're sending it to a colleague, get rid of everything except the one you want to export. So you can't delete the first two, they're hard-coded, but you can delete everything else. So if I just go through here and remove everything, here we go. Let's say I wanted to give these 3 total station formats to a colleague. I delete everything I can. I can't delete these 2, that's okay, except the ones I want to export, and then do save as, give it a name, and that file can now be merged in. So I'll demonstrate quickly the merge operation. Let's cancel out of here because I don't want to save all those I don't want to save the deletions that I did. Come back in and now let's delete those. And when you do a merge operation, it takes the formats that are in the file and adds them to your list. So there they are. There's the 3 formats that I just saved out. And those files end up by default in your settings and layouts folder. But you can put them anywhere because there's an open and merge function which allow you to browse the hard drive. Right, so if you've gone to the trouble of making a nice import format, then you certainly want to save it and reuse it. Let's take a look at a format that is pretty much set up, and let's make sure that we've got all our import format structure the way we want it. So I'm going to take a look at this one. And let's take a look at all the settings that have been made here. Now, connecting things up so that they become a polyline can be tricky. And I've shown you already that if the points are not in order, you can get bad results. Sometimes you can break up polylines by using this adjacent function. So for example, in this file, all the Thalweg point codes are adjacent to each other, and all the PW1 present water line 1 are adjacent to each other. But that's one way to keep them separate. And if you do that, then you don't really have to be too careful about point code naming, because all you need is a break between point codes and they'll be grouped, they'll be clustered. I prefer myself to use connect all by code and make sure that my codes are well defined. But as I mentioned earlier, it's also possible to put in a special character in your point code at survey time that says this is the end of a break line or this is the end of a string. And that way you could, for example, all your ditch line point codes could be DL, but every time you get to a driveway, you put in an exclamation mark on the point code, and then it won't connect up to the DL on the other side of the driveway. What else have we got in there that's interesting? So yeah, I like to use connect all by code. There is an option here to simply skip a point code. So just don't read it. You can choose whether it's 3D or not, and you can also include whether it's added to the model. So if you survey the top of a fence, for example, and you want to build a surface model that represents the ground, well, you don't want to include that in the model. It can still be a 3D point, so you can see the elevation of the top of the fence, but it's not part of the model. So that's an option. You can have points hidden, and of course, line types and colors and hatching. So setting these things here means you don't have to do it later, but all of these properties can be set later, and sometimes that's just the best way to do it. Right, I think I've covered all the import structure. That's really a lot of information, and sometimes, like I say, the best way to get things working is to just try and open and see what you've got, and then try again. And once you get it working, save your options into your default setup or to another file. Now I'd like to show you some of the issues that need fixing when you read in an ASCII file. They happen all the time. They happen over and over again. So let's start with a different file. I'm going to use this one. Right, well that looks good. If I zoom in here, you can see I've got break lines connected. The survey was done section by section, which kind of makes sense. the points were surveyed in the right order, but they're not clustered. So for example, this one here is a ditch right, DITR, and the next ditch right is up there, but there's a whole bunch of points in between because it was surveyed cross-section by cross-section. Worked great, brought in my break lines. Now let's look at the issues. So here we've got an intersection, we've got a road coming across here that joins into this road and that road, and these point codes are all mixed up. Sometimes you can see what's going on and just fix it by hand. I'll demonstrate with the center line, but it really helps if you hide everything except the feature or point code you're working on. So I'm going to select everything except the feature I just selected, which is the center line, by using invert selection, and I'm going to hide all those features. Turn off displayed, apply. They're still visible because they're still selected. As soon as I click to select something else, there we go. Now I can see what's going on clearly, and I don't have to worry about selecting the wrong feature. And I can fix this up here. I'm going to use my break functionality here, break at current point over and over again. So I break there and then get rid of this point. Do the same thing here, Control Q break. This time I don't want to get rid of the duplicate point. Here, Control Q break. And now I think if I select this feature and this feature, shift click, whoops, shift click, and then join them together, Control J, that's center line number 1. Actually, I did want to get rid of that point. Well, no, I'm just going to pick it up and snap it down here. And then I'm going to shift click and select the other half of that piece of center line and join them together. And there, that's better. So that's all doing it by hand. Now let's look at another problem here. So I just did Control A to select all, and I can see, well, this feature looks terrible. This one here, shoulder, this one's bad too. This is EPR, edge of pavement right. Okay, I'm going to select that one. Make sure it's visible. And what should I do for this? So what I'm going to do is I'm going to break it here because the end looks good. The part going north looks fine. And then this one, I am going to explode into points. And now I can clearly see what the heck's going on. Okay, these ones are joined into a string. Those ones are joined into a string. And well, let's hide this. I don't need the center line anymore. And I could probably do this with a mouse selection. Sometimes you get lucky and you can just do that. Control J, and I bet you that continues on to there. Shift, click to select, and Control J join. That's one pavement right. And then if I select these, again, I got lucky here. I could use the mouse, but sometimes it's hard to use the mouse, so you can draw a selection feature. So I'm just going to draw a temporary feature, mouse, like so. Click to create a point, click again to anchor it down. Close. This isn't absolutely necessary, but it sure makes it clear what's going on. There's a polygon. Select by boundary, and the selected feature becomes a tool for selecting other features. Don't keep this one. Certainly don't include hidden because they're all over the place. And there, I've selected all those features. And now I can join them. And this is now useless. I'll delete it. So that's another tool that can really help. That polygon, by the way, could be made from the center line. Oh, and I'm going to answer a question because it's quite pertinent. What about all those speed keys I'm using? How can you tell where they are? Well, it turns out that they are always in the ribbon, and I'll just demonstrate that in 1 second. First of all, crossing brake lines. Let's look at crossing brake lines. Again, it happens all the time. So this time I'm going to insert a file that I know has a crossing brake line. I'm actually going to open it. I've used this for a lot of examples, so you may have seen it before. So here's my data set. Looks great, but the surveyor went out twice. So I can add more data using insert. Notice when I'm in the ribbon that everything has a little drop down, help text, and often there's a speed key, this one, Control J. And same with the pop-up menus. Select feature, all is Control A. Modify selected features, and there's a join operation in here, Control J. So you can find those speed keys using the menus or using the ribbon, and then save yourself some time. Okay, I'm going to insert from the home ribbon, insert a file which has more survey data in it. When you use file insert, you can select multiple files at the same time, which is pretty handy. I only want this one. Okay, and it's this one. When there are multiple options that have the same extension, sometimes you're prompted to choose, and I want the third one. And it's bringing in the data. Fine, there's the new data highlighted. And you can see it was just a little extension here, and off to the left, some more data points were taken. I can imagine, somebody went to design this section of road and said, I need to know what the ground is like out here. Get back in your truck and go and do some more survey and give it to me. Okay, so we've got the survey, and now I'm going to generate a model. And when I generate a model, I can tell it how far is the largest distance I can use to connect points. I'm going to choose 50 meters here because the surveyed cross sections are quite a lot closer than that. They're about 20-25 meters apart. And I'm going to build this model. Let's skip the contours for now. No, I'm going to put them in. What the heck? Crossing brake line. Okay, now there are coordinates here, but really writing down those coordinates is the hard way. Don't bother, just say, oh yeah, I got crossing brake lines. Yes, I know I have crossing brake lines. And now I'm going to use the tools built into the software for finding the crossing brake lines. And here's how we do it. First of all, bring up the points window. The points window appears over here in the panel section, and you can change the column headings. The default in the software has the column headings set up to show this thing X brake. But if it's not in there, you can add it. Crossing brake line point. Okay, so the points window can display things like XYZ coordinates and name, that makes sense, as well as this property crossing brake line. Now I need to select all the features that I want to see. I might have the wrong ones in here now. So select by property. There's a property called crossing brake line. There's also a property called brake line if you want to see them all, but I just want the crossing ones, and everything else I'm going to ignore. So those features are now selected, and I'm going to add them here to the points list. So that's the eyeball button. Okay, now I'm looking here. I wonder where that crossing brake line is. Just go up to my points window and click on it, and it jumps me over to the crossing brake line selected, and the point shown is the one before the crossing brake line. So the next point is after the crossing brake line. So it's in there. It's in there somewhere. If I zoom in, I can see pretty clearly what's going on. This ditch line here goes across like that, and this ditch line there goes over there, and they cross right here. So the elevation there is undetermined. It's something between these two lines. They may have similar elevations, but in general, they're not identical. So here's the fix. Break lines are allowed to cross each other as long as they share a point. I could throw away one of these points. Here's an option. I could pick this up and snap it on the end there. Oops, I snapped to the contour. When you're doing this kind of work, it kind of makes sense to delete contours. Right, so I could snap it to the end there. Now I need to undo that because there's another option. And again, I'll delete the contours. The other way, let's keep both points. And I've got this feature selected, right? It's highlighted pink. I'm gonna insert a point like so. That would add a point close to the end. That inserts a point. Click to create a new point and snap it to the end of the other one. And same here, select this feature, create a new point and snap it to the end of the other one. So now they're still crossing, they still overlap, but they share points where they cross. And if I generate the surface again, no more crossing break line warning. Now there's another problem in this model, and let's look at the 3D, and I think it'll kind of jump out at us. 3D window is great for finding issues with the model. You can see here, this looks pretty reasonable. It looks like a road. The break lines are defining the ditch line well and the top of bank and everything else. But if I look up here, you see there's a hole in the model. So that's pretty visible. There's a gap there. But if you weren't sure how many holes there were, or if there were maybe some small ones, you could also use this function, tin operations, create tin boundary. And in this case, I actually created two features. And if I use the tab function to shift between them, you can see there's one on the outside of the model, and there's the other one on the inside of the model. That's my hole. I don't need those anymore. I'm going to delete them. So why did I get a hole in the model? The reason is because this green feature is a break line. You can see it in the properties here, and it's long. That particular segment is over 50 meters long, 79 meters. And that means that when I built my model and I chose a maximum triangle length of 50, it had to fail. Break lines must be triangle sides. The triangle, you could make a shorter triangle by going across this way, but that's not allowed on a break line. And this is actually a really good way to find break lines that should not be connected together. For example, ditch lines that are crossing, you might have a section of road with ditch, and then the road goes into fill and there's no ditch, and then a kilometer down the road, you're back into ditch. If those two ditches are connected, you're gonna have a break line segment that is huge. It's gonna be a kilometer long. So there's a tool for that. I don't really have time to cover much here, but let me just summarize quickly. In the features panel, you can display, nope, we're in the wrong panel, sorry. It was the points panel again. In the points panel, you can display, right, the options are this guy here. You can display the length of each segment, forward leg, HD, that's the length of each segment. And we're looking at that break line right now. There it is. And if I sort by length, Oh, I said it was 79, but it's actually 57 is my long segment. But if you saw something in here that was like 507, well, you know that's probably not reasonable. Sometimes all you need to do is look and you can see the problem. Long break line segments will generally screw up your model. In this case, it didn't. And there's a couple of different solutions here. I could say, yeah, this is real and just change my triangle length, or I could remove the long segment. So I'll do that by breaking here and then selecting that segment and turning off its break line property. Then rebuild. Problem solved. But while I was looking there, I saw another one. This is, again, typical. What's going on here? Well, there was a surveyed point there, which represents the edge of the road. It's called EP, edge of pavement. And this feature, which is the shoulder, doesn't have a point there. That's the nearest point right up there. I just selected here and, oh, it gives me that point down there. So what I'm seeing here is that the edge of shoulder break line was missing a point. And again, I got some contours that are kind of in the way, so let's get rid of them. I'm just going to fix that up. So I'm going to select the shoulder, edit it by creating a new point, snapping it to the road feature, like so. Now it's got the point that it should have had, because this survey point should have been tagged as survey or shoulder, but it was tagged as edge of pavement. So now that that point has been added to the shoulder, I can safely take it out, click to capture, delete to remove, take it out of here. No matter how carefully you set up your design for point codes and import formats, there will be mistakes. And so you can use the software, the tools built into RoadEng later or in terrain tools to fix up various problems. Just double checking that I covered all the fix. We covered an out of order break line, joining points using a polygon. Oh, bad elevations, right. Again, with this one, we had a couple of bad XY coordinates. Very often you get bad elevations. Let's use this model to demonstrate that. So I'm just gonna modify this one, and maybe you didn't know you could do this, but you can modify the coordinates of any point. So if I type in a bad elevation here and then rebuild my model, generally you can see problems like that. There's my point. Let's rebuild the model. And there's my issue. If that point just has a garbage elevation in it, all I need to do is find it and select it. Often it's easier to find things if you have this track mouse turned on in your 3D options. Then you can see the cursor moving around. So where is that point? Oh yeah, it's right here. You can see the cursor moving in both windows. And you can select in the plan window. You can also select in the 3D window. And it's really easy to select the contour by mistake. So again, just be a little bit careful, or delete the contours. They're not really necessary. They're easy to recreate. So that elevation point is called spot. I don't like the elevation. It looks wrong. And the easiest way to take it out of the model is just turn off this model checkbox here. Leave the elevation defined. It's still there. It was actually surveyed for some reason. Maybe it's the top of a fence post or something. But it's no longer part of the model. Finally, assuming you've made a nice surface, and let's go back to that creek surface because that one's pretty cool. How would you export it? So this one is set up so perfectly that it comes in without any modifications and builds a great surface. I don't know how long this should be. Let's just leave it at 150 and see what it looks like. And you can see in the 3D window, this is a pretty decent surface. We've got break line for the thalweg, the middle of the creek, the high water mark and the other high water mark, low, high, maybe. We've got a break line along the road, got some break lines in the abutment, and it looks like a nice surface. And how could I save that out? Well, I can do save as. This might be useful, 3D Mesh OBJ, if you're using kind of a generic 3D viewer. But if you want to go back to a total station instrument or machine control, use LandXML. So LandXML is, am I in the right folder? Yes. There's no options in the terrain. It builds a surface and it puts it in the file, and you can open that in your CAD program if you want, or total station machine control devices. If I were to make a road design, now I'm leaving the terrain module. I'm going to go to the location module. Okay, I'm going to open a road design that was made on that Hart Road. Right, how about this one? Looks like that was created in version 10. Version 10 is coming out, I hope, in a few months. It's out in beta now if you want to test it. And I've made a road. Okay, I've designed a road. I got plans and profiles of cross sections, and I want to export that for stakeout. So I do save as. I can create stakeout notes as documents, Excel documents, but again, LandXML is kind of the file format of choice if you want to send it out to a total station instrument or a device for machine control. And in the location module, you can export the alignment. In fact, you have to. And you can choose to export surfaces and cross sections if you want. And by surfaces, you can choose the subgrade designed surface or any of the other surfaces, including the survey topo, which is the background terrain. And the sections are there's a lot of control for cross sections, and you need to set these options depending on what you want to do with it. But if you don't export cross sections, then those options are irrelevant. So now I'm just exporting alignment and subgrade surface. Phew. Thank you for your patience. It's gone a little over time here.
Awesome. And with that, I'm probably going to wrap us up. We're only, casual 22 minutes overtime. So thank you everyone for joining us today. Stay tuned. Lots more exciting webinars on our calendar coming up. You can access them all through our softry.com/webinars. And thank you very much.